Okay, here we are on our second problem for chapter 9. We're going to do E9B.4. That was a dot. Okay. And it says a long straight wire carries a current of 200 amps. I equals 200 amps. It says what is the magnetic field strength at a point 3 centimeters from the wire? R equals 3 centimeters, which is 0.03 meters. Of course, you guys know that. And so here's our picture. Nice long wire carrying a current I of 200 amps. And what is the magnetic field strength? So it's only asking for magnitude, and we're looking at a distance. Let's say we'll put our point down here, and it's 3 centimeters from the wire. Okay, so if you scan through your book, you'll find equation 9.12 gives you the strength of the magnetic field from a long current carrying wire. And so here's the equation. It's B bar. Remember, B bar is C times the magnetic field. So this magnetic field has units of Tesla. This magnetic field has units of newtons per coulomb, which is nice because it's very analogous then to the electric field. Yeah, that's it. Okay. So B bar is 2 times K, the Coulomb constant, times the current I, divided by the speed of light C, and divided by our distance away from the wire R. This is pretty easy. This is a nice little plug and chug. And so if you're watching this, you might want to just listen to the hint that this is going to be the reading quiz tomorrow. Okay, so we have a 2 multiplied by K, which is 9 times 10 to the 9 Newton meter squared per coulomb squared, times our current, which is 200 amps, and we're dividing by the speed of light, 3 times 10 to the 8th meters per second. You want to memorize that one if you haven't already. And then dividing by R, which is our separation from the wire, 0.03 meters. Okay, so we have a meter down at the bottom, cancels out one of those meters. And then we have a meter over here that cancels out the other one. Okay, and then we have coulomb squared per second, or 1 over coulomb squared, 1 over seconds, and we have an amp. But remember that an amp, 1 amp, is just 1 coulomb per second. Okay, so that gives our amps go away. Here's a 1 over second on top, 1 over second on bottom. Those go away. We have a coulomb divided by a coulomb squared, so that goes away. So we are left with newtons per coulomb. That's good, because that's what we said our unit should be. Okay, and now plug this all into your calculator. I got 4 times 10 to the 5th newtons per coulomb. It's just the magnitude of B bar, right? Okay, and I hope you did too. So just as a little aside, what would the direction be? For this, we want to use our right-hand rule where our thumb is going in the direction of our current, and then our fingers are curling around in the direction of the magnetic field. So they're coming out of the page up here and going into the page down there. So as I drew it down here, the magnetic field would actually be directed into the page, B and B bar, and coming out of the page up here, right? All along the wire, it's coming out on this side, going in on this side. That's more than the problem asked for, but just a little extra fun for you. Okay, that's it.